Okay, if you want to pause it and read the problem real quick. So we have SAT scores, which follow roughly normal distribution. We're going to say a mean of 500, standard deviation of 100. We can write it like this in shorthand. You'll see that sometimes. In reality, the mean I think has been a little bit higher in the past, but this is roughly good enough for this problem anyway. So what portion of SAT test takers score above 650? So we're going to assume throughout the course of this problem that we're dealing with a normal distribution, mean 500, standard deviation 100, to answer these questions. So the first thing we might do is just draw the distribution. So 500 is at the mean. We know the standard deviation. Each standard deviation is worth 100. So we could draw a single standard deviation over there to 600, draw another one over to 700. Our 650 is going to be right about in the middle there. And we want the portion that scores above a 650. So that's why I shaded the area to the right here instead of the area to the left. These would be all the people who scored above a 650. And that's what we want to find out, that portion. First thing we want to do is convert this normal distribution to a standard normal distribution. And we can do that by taking a look at how many standard deviations above the mean a 650 is. So the z is just a short way to say how many standard deviations above the mean are you. And we could look up here and we could see, well, we're more than one standard deviation above the mean. We're not quite 2, so somewhere in between 1 and 2. If you have an observant eye, you might know we're exactly halfway in between 1 and 2, 1.5. You may not even need the formula here, but let's go through it. A lot of times it's much messier than these numbers. So this is the formula to calculate a z-score based on a given raw score. So we take our 650 minus 500 divided by 100. We end up with 1.50. I would keep that 1.50, those two decimal places, just for the sake of looking it up on Table A. So let's take a look at what Table A looks like. What does a z-score of 1.5 look like on Table A? Okay, wow, a lot of numbers there. What are we looking at here? The Table A really is just a conversion table, just like you might convert inches to centimeters, meters to feet, something like that, Celsius to Fahrenheit. We're going to convert z-scores, which are given here along the side and the top, and convert it to the area to the left of that z-score, the area of the standard normal that's to the left of any given z-score. So the first page is going to have all of our negative z-scores. We're actually looking for a positive z-score of 1.50, so we're going to zip to the second page of Table A. We're going to get our first two decimal places, the 1.5, from this left column here, so that puts us right here. And then that hundredths place, where we have a 0, we're going to get that across the top. So 1.50 would be right here. If we had been looking for, say, 1.56, we would have gotten 1.5, and then right here to the 0.06 column. That 6 hundredths would put us right here. But we had 1.50, so that's where we get 0.9332. So what does that mean? Okay, that 0.9332 that we get when we look up the 1.5 on the chart, that tells us 0.9332, or if we want to say it in a percent, we can shift the decimal over 2 to the right and get 93.32%. So 93.32% of this distribution, this normal distribution, is below a z-score of 1.5. Another way we can think of that is 93.32%, roughly, of the test takers will score below a 650 if we want to convert it back to those original units. But notice that we wanted this blue area, and what we got by looking up Table A always gives you the area to the left of the z-scores that are less than any given z-score. So we have this, we want this. Luckily we know the two add up to 100%, so that's what I'm talking about right here. So if we want the blue area, we just start with 100%, subtract out the red area, and that would give us the blue area there, or 6.68%. So what does that mean? That means about 6.68% of SAT test takers are scoring above a 650. And 93.32% are scoring below a 650. So the next question then is, what portion of SAT test takers score between? So instead of a single chunk here off to one of the tails, we want the area between 450 and 650. I'll show you right down here on the final answer. We're looking for this blue section here. So table A, this is from a kind of a geometrical perspective here. Table A is going to always give us the area to the left of something. And so we can't get the area in between two directly from table A. But what we can do is get the area to the left of this. That'll give us everything here. And then we could get the area to the left of this and essentially slice off that tail that we don't want, slice off that portion we don't want, to leave us with only that blue portion. That's our strategy here. So notice we already have the percent to the left of 650. We got that right here in part A. But we don't know how many test takers scored below a 450. So same as in part A, we're going to put that 450, convert it to a z-score. So we're half a standard deviation below the mean now. That 0.50, that negative means we're below the mean, and 0.50 is half a standard deviation. So we're half a standard deviation below the mean. That's what we'll see right here. We look it up on table A. Let's take a look. Negative 0.50. Going to have to go back up to the negatives here. So our z-score is negative 0.50. We're getting the 0 there. To get 0.3085. So in other words, 30.85%, 0.305 or 30.85% of the distribution is below that z-score, or 30.85% of the test takers are scoring below a 450. So we can essentially get rid of them. We know that this entire area, maybe do it over here, the entire area is 93.32%, and we know that this red portion here that we don't want is 30.85%. So if we subtract that from 93.32, that's where we get 62.47%. So roughly 62.47% of the test takers of the SAT are scoring between a 450 and a 650.